Welcome to EDU World Space.
Okay, so this is the circuit and the question has given us the values of the resistance R1, which is parallel to R2, and R1 is 3 ohms whereas R2 is 6 ohm, and both of these resistors are connected in series with a third resistance R3, which has a magnitude of 5 ohm, right? And the battery has negligible internal resistance, and the current flowing through I2 is given, right? And that is I2 equals to 4 amperes. Okay, so the question asks us in part A, what are the currents through I1 and I3? So as you know, since R1 and R2 are in series, the current are inverse to their resistance. So I1 by I2 equals to R2 by R1 by R1. So from this we can calculate I1. I1 should be equal to I2 times R2 by R1. Now we know the value of I2, that is 4. We know the value of R2, that is 6, and R1 is 3 ampere. So 6 for the 24 by 3 is 8. So 8 ampere is the current flowing through R1. Now I3, to calculate I3 is the sum of currents I1 and I2. So I1 plus I2. This gives me 4 plus 8, that is equal to 12 amperes, right? Okay, let's move on to part B. What is the EMF of the battery? Simply EMF of the battery is equal to, since we don't need to take care of the internal resistance, we can just say EMF equal to the total current flowing through the system times the equivalent resistance of the system, Req. So the current flowing through the system is, since I1 plus I2 and I3, these are in series, so current flowing through the circuit is 12, and the internal equivalent resistance is R1 is parallel to R2, and these are in series with R3. So this is the internal resistance, right? Sorry, equivalent resistance. So this is equal to 12 times R1 parallel R2. So 3 parallel 6 plus 5. Now 3 parallel 6 is 6 3s are 18, divided by 6 plus 3 9. 18 by 9 is 2. 2 plus 5 is 7. 12 into 7 is 84. So this is the EMF of the battery. Anything else that you need to determine? No. Okay. So we are done with the solution of this problem. Thank you for watching.